Next, we look at grouped data. Now again, when the amount of data is too large, we often categorize it into classes. For example, if these are the scores in an exam, if you form a frequency distribution table, it will still be long. Instead, you can group the scores into categories, say with a range of 10 marks. To do this, you look at the highest and the smallest scores. For this case, let's have a range of 10. So we would have 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Now, when working with grouped data, there is a new column that you must form. That is the midpoint. In the column for classes, we have class limits. In the class of 50 to 59, 50 is called the lower limit and 59 is the upper limit. For the class of 70 to 79, 70 is the lower limit and 79 is the upper limit. To find the midpoint for each class, we get the average of the upper and lower limit. So for the first class, we would have 50 plus 59 over 2, giving us 54.5. Second class, 60 plus 69 over 2 gives us 64.5. Third class, 70 plus 79 over 2 gives us 74.5. Fourth class is 84.5 and the last one is 94.5. The midpoints now represents our observations, x. Any other column will be formed depending on the formula. We calculate the mean. To calculate the mean for grouped data, you can use the direct or the assumed mean method. For the direct method, mean is given by summation of fx over the summation of frequency. Notice that for grouped data, x is the midpoint. From the formula, it means we will need another column for fx. We multiply each midpoint by the corresponding frequency. 54.5 times 1 is 54.5. 64.5 times 7 is 451.5. 74.5 times 4 is 298. If you proceed like that, you will get the fourth one, 253.5, and the last one, 94.5. The summation of frequency is 16. The summation of fx will be 1152. And therefore, the mean is equal to 1152 over 16, giving us 72. For the assumed mean method, mean is given by A plus summation of FD over the summation of frequency. Looking at the formula, it means we choose an assumed mean A and then get another column for D and another one for FD. Recall that D is equal to x minus A and that x in grouped data are the midpoints. So let's take an assumed mean of 74. We calculate D for each class. First one, 54.5 minus 74 is minus 19.5. 64.5 minus 74 is minus 9.5. 74.5 minus 74 is 0.5. 84.5 minus 74 is 10.5. 94.5 minus 74 is 10.5. Now we multiply the deviations and the corresponding frequencies. 1 times minus 19.5 is minus 19.5. 7 times minus 9.5 is minus 66.5. 4 times 0.5 is 2. 3 times 10.5 is 31.5. And 1 times 20.5 is 20.5. The summation of FD will give us minus 32. And therefore mean is equal to the assumed mean 74 plus minus 32 over 16. That is equal to 74 plus minus 2, giving us 72, the same mean. The model class is the one with the highest frequency, that is 60 to 69.